how to select the pump for our house, and how to calculate the capacity for it, we will study in this video. To calculate the horsepower for a pump, we have two formula. Number one, horsepower equal to H into Q into Hg divided by 3960. H head in feet, Q flow in GPM, Hg specific gravity of fuel, which is for water, equal to 1. The second formula is horsepower equal to P into Q into Sg divided by 1714, where P is the pressure in PSI, Q is the flow in GPM, and Sg is the value 1 for water. If you have 4 members in your family, a general practice is that a person will consume 200 liters of water in a day if he is living in the main city. If he is living in villages or in outskirts, then you can take it from 200 to 130 also. So 4 member will use in a day 800 liter of water, and normally we select the water tank size to have water for minimum 2 days. So 800 into 2, it will be equal to 1600 liter capacity. So the nearest water tank size will be 2000 liter. So we will select a water tank of 2000 liter for this family. Let us convert this 2000 liter into US gallon. So 2000 liter is equal to 528 US gallon. If we need to fill our water tank in 15 minutes, then we will divide this 528 by 15, and we will get the GPM value, which will be equal to 35. If we are using schedule 40 PVC pipe to transfer water from the pump to the water tank on the roof, and we have already calculated the GPM required, which is 35, then we will see the pipe size from this hydraulic table. If we see the pipe size 1¼ inch, then we see the velocity is 7.51 and the loss in feet is 14.7. Both are higher. Normally we take the velocity of 5 feet per second, and the friction loss should not be more than 5 psi per 100 feet. So both these values are higher. Then we will go for the next pipe size, which is 1½ inch. Here you can see this velocity is near to 5 and the friction loss also 7 feet. So both are accepted. Then we will select the pipe size 1½ inch. So we have selected from the hydraulic table a schedule 40 PVC pipe of diameter 1½ inch for 35 GPM with a velocity 5.52 feet per second and water head 7 feet. When this pump located at the ground floor will work, it will lift the water from the ground to the roof where we place the water tank. Then there will be two types of pressure drop. One will be due to the elevation difference, and the second will be due to the friction loss inside the pipe when the water will flow inside it. Let us calculate the first one. Assume that we have placed our water tank on the roof at a height of 30 feet from the ground. We know the formula. If we lift the water in a pipe to 1 feet, then the pressure drop is 0.434 psi. When we will lift the water to the 30 feet, we will multiply this value by 30 and we will get the total pressure drop due to lifting of water to 30 feet, and it will be equal to 13.02 psi. If we need to convert this value into feet, then we will multiply this value by 2.31 and we will get the result 30.08 feet. Let us now calculate the second pressure drop, which is due to the friction loss inside the pipe when the water is flowing. Let us assume our total pipe length equal to 40 feet, and as we already selected from the hydraulic table, our PVC pipe 1½ inch for 35 GPM with a velocity 5.52 feet per second with a head loss of 7 feet per 100 feet. We will multiply our total pipe length with this 7 and divide it by 100, then we will get the total pressure loss due to friction inside this pipe, which will be equal to 2.8. This is normal practice, that way we add 50% to it for the loss inside fitting and walls. Then the total friction loss inside the pipe will be 2.8 into 1.5, and it will be equal to 4.2 feet. Now let us calculate the total pressure drop. First we have calculated the pressure drop due to the elevation height, which is 30.08, and the second value due to friction loss we have calculated, which is 4.2. Then the total pressure drop will be equal to 34.28 feet. As we know, the formula to calculate the horsepower is equal to HP equal to H into Q into SG divided by 3960. Let us apply our calculated value in this formula. We have the total pressure drop 34.28 feet, and we have the flow 35 GPM, and specific gravity for water is 1. Then we will get the result 0.30 HP. If our pump efficiency is 60%, then we will divide this value by 0.6, then we will get the result 0.5 horsepower. It means we need to select a pump of half horsepower for this building.